Hi, today we're going to talk about the Pythagorean theorem converse. Remember, the Pythagorean theorem says if a triangle is right, then a squared plus b squared equals c squared. If I want to do the converse, I need to remember that the converse is when the hypothesis and conclusion have been switched. My key word is switched. So I'm going to take my hypothesis, a triangle is right, and my conclusion, a squared plus b squared equals c squared, and I'm going to switch them. So I'm going to still start with if, but instead of if a triangle is right, I'm going to use my conclusion. If a squared plus b squared equals c squared, then my hypothesis, a triangle is right. So if you have three side lengths of a triangle and you try them in the Pythagorean theorem and it works, you get an equals, two sides that are equal to each other, then you know you for sure have a right triangle, okay? But what happens if it doesn't work, okay? The two sides are not equal to each other, okay? If I look in my first situation here, I can see that my legs being squared are less than the hypotenuse being squared. Okay, so what that means is my hypotenuse is too big, or my legs are both too small. If my hypotenuse is too big, then that means the angle across from it that's supposed to be 90 is bigger than 90, which makes that obtuse. Okay? And then if I look at the next section, if I end up here with a greater than, my legs are greater than the hypotenuse, that's going to mean my hypotenuse is across from an angle where my legs ended up being too long for it, or my hypotenuse is too small. It's too small to be across from a 90-degree angle, which means it's across from an acute angle. Okay? So if I'm given three sides of a triangle, I can use the Pythagorean theorem to determine whether the triangle is right because the Pythagorean theorem works, or if it's obtuse, the one that we think is the hypotenuse is too big, or it's acute, the one that should be the hypotenuse is too small. But how do I know if I have three sides of a triangle? How do I know which one I should test as the hypotenuse? Okay, well, what we want to know is which one, if it was a right triangle, how would I identify the hypotenuse? I know it's across from the right angle, but I don't know if it has a right angle. What else do I know about the hypotenuse? I know it's the longest side. So when you're given three sides, you want to use the one that's the longest or the biggest, okay? So let's do a couple of examples of this. When I look at these first two, and I look at the first one, 15, 20, and 25, the first thing I need to do is say, if this is a right triangle, which one would be the hypotenuse? And again, it's going to be the largest one. So that means 15 and 20 are my A and my B. So I'm going to test 15 squared plus 20 squared. And I want to know, is that equal to 25 squared? Okay, so in my calculator, I'm just going to type 15 squared plus 20 squared. When I do that, I get an answer of 625. When I type in 25 squared in my calculator, I also get 625. Okay, so these two are equal. They're the same. So if they're equal, then that means yes, this is a hypotenuse. This is a right triangle. Okay, let's look at number two. For number two, when I test it, The one I'm going to say would be the hypotenuse is the longest one, so that's 24. So I'm going to try 16 squared and 21 squared. I'm going to add those two together and see how does that compare to 24 squared. All right, so in my calculator, 16 squared plus 21 squared gives me 697. Okay, and 24 squared is 576. So my symbol then is going to be facing towards the bigger side. The one we thought was the hypotenuse is too small to be a hypotenuse. So that means this triangle is an acute triangle. Okay? All right, this works even if I don't have a picture. When I look at the next examples, I don't have a picture, but that's okay, because if I have 10, 11, and 14, I know that the one that would be the hypotenuse, if I have a hypotenuse, is going to be the longest one. So that would be my 14. So is this a hypotenuse is what I want to know. Okay? So I'm going to take the 10 squared plus the 11 squared, and I'm going to compare that to 14 squared. 10 squared plus 11 squared is 221. 14 squared is 196. Okay, so when I compare those, the side on the right that's supposed to be the hypotenuse is again too small. So that means this triangle is acute. It's an acute triangle. Okay. Number 4. Now on this one, they don't always give me my numbers from small to big. Usually they do, but not always. So if I have a square root, I want to check that. So I'm just going to type 3 times the square root of 34 in my calculator and see what it is. It comes out to be 17.493. So 17 is bigger than the 15 and the 9, so that would be my hypotenuse. Okay, so I'm going to check 9 squared plus 15 squared. And I want to know, does it equal 3 square roots of 34 squared? Now when I put that in the calculator, I'm going to start with a parentheses so I square everything. 3 square root of 34. And if you'll notice, the calculator's already going to build in that close parentheses for you on our Inspire calculators. So you need an arrow outside of that so you end up with your square outside. Okay? When I do that, I get 306 on the left-hand side. And over here I get also 306. Since my two sides are equal, that means this is a hypotenuse. It's just right, not too small, not too big, but just right. So that means it's a right triangle. Okay, let's try 2 more of these. All right, 8, 10, and 12. So that means my biggest side is going to be my 12. So that's the one that, if this is right, that's the one that will be my hypotenuse. So 8 squared plus 10 squared compared to 12 squared. 8 squared plus 10 squared is 164. 12 squared is 144. So that means that the one I thought was a hypotenuse is too small to be a hypotenuse. Small. So this is an acute triangle. Okay. And again, this still works for the same exact way if you have a decimal. Don't let decimals scare you. We do the same thing. 8.2, 4.1, and 12.2. 12.2 is my biggest side. So I'm going to do my 8.2 squared plus my 4.1 squared, and I'm going to compare that to the 12.2 squared. Okay? When I do 8.2 squared plus 4.1 squared in my calculator, I get 84.05. When I do 12.2 squared in my calculator, I get 148.84. So when I put my inequality symbol, it opens to the larger side. It's a less than symbol. That means the side I thought was going to be a hypotenuse is too big to be a hypotenuse. So that means this triangle is an obtuse triangle. Okay? All right, let's look at with some pictures. Now, when I look at number 7, I immediately look at it and say, oh, well, that's clearly obtuse. But nothing in my picture says anything's to scale. So just to be safe, I'm going to check and see if it's obtuse or not. Okay? So 17 is my longest. That means that's the one I'm going to test as my hypotenuse. So I'm going to do my 15 squared plus my 8 squared, and I'm going to see how does that compare to 17 squared. Okay? 15 squared plus 8 squared is 289. 17 squared is also 289. So even though this triangle looks like it's obtuse, this picture is not to scale. This picture is classified as a right triangle because I ended up with 2 equal sides. Okay, number 8, same thing. This one looks like it's maybe an acute triangle, but let's test. My largest side is 25, so if I have a hypotenuse, that would be my hypotenuse. So 24 squared plus 7 squared, how does that compare to 25 squared? 24 squared plus 7 squared is 625. 25 squared is also 625. So these, again, for the second time, I've got an equals, which means this is also classified as a right triangle. Okay, so again, this is just kind of to show you that even if it looks obtuse or it looks acute, you have to go with the math. You can't trust your eyes. You trust your math, don't trust the eyes. All right, let's look at number 9. Okay, number 9, my longest side is 8, so I think that's the hypotenuse if I have a hypotenuse. So my other two sides, 6 squared plus 7 squared, equals, or maybe equals, shouldn't put the equals there yet because I don't know if it's equals. It looks like it's maybe a right triangle, but I already know I can't trust my eyes. On this side over here, 8 squared. Okay? 6 squared plus 7 squared is 85. And 8 squared is 64. Okay? All right, so on this one, the side that I thought was going to be the hypotenuse, oops, I wrote that backwards. My symbol needs to face the larger side. The side that I thought was going to be a hypotenuse is smaller, so it's too little to be a hypotenuse, which means this triangle is really an acute triangle. Okay, number 10. The longest side is 14, so 10 squared plus 8 squared, how does it compare to 14 squared? Okay, 10 squared plus 8 squared is 164. 14 squared is 196. So my inequality faces the larger side. The side I thought was the hypotenuse is too big to be a hypotenuse. That means this is classified as an obtuse triangle. Okay. All right, oftentimes problems that look like these next ones, and it says, can the following squares form a right triangle? What that means is if I were to kind of pull these squares together, so I've got this square that has side lengths of 9, and this square that has side lengths of 10, and this square that has side lengths of square root of 19, if I were to kind of pull those together so that it made a triangle, if I like tightened them up and dragged the corners together, would it make a right triangle? Okay, so I need to do the same thing. It's basically the same as when I had just 3 numbers, except they gave me a picture with it. Okay, so I need to know which one is the biggest thing. So what I like to do is I like to just make sure that my picture, because maybe it's not to scale, square root of 19 comes out to 4.359. So that means my 10 is still going to be my biggest, so that's the one I'm going to test for C. So I'm going to do 9 squared plus the square root of 19 squared. How does that compare to the 10 squared? Okay, so 9 squared plus the square root of 19 squared, when I type that in my calculator, and I want to make sure it looks like I have it here with my parentheses, I do end up with 100. And then 10 squared is also 100, so they're equal. This triangle, if I use these squares to make a triangle, it would be a right triangle. So my answer here is, can the following squares form a right triangle? I would say for this one, yes. Okay, let's look at the next one. When I look at the next one, I'm going to do the same thing. If I took these three squares, my 16, the 30, and the 34 squares with those side lengths, and I pulled them together so that they made a triangle right in here, would that triangle be a right triangle? When I look at the three sides, 16, 30, and 34, the one I would call the hypotenuse would be the longest one, the 34. So 16 squared plus 30 squared, how does that match up with 34 squared? 16 squared plus 30 squared is 1156, 1156, and 34 squared is also 1156. So the two sides are equal, which means this does make a right triangle if I put them together. So when I'm answering my question, can the following squares form a right triangle? Again, on this one, I would also say yes. Okay. All right, and that's all there is to the Pythagorean theorem converse. Thanks for watching.